All right, so we'll finish up a 2122. Maybe get just a peek at 23. I will post the quiz prep 2122 on Tuesday, 23 and 24. Quiz prep for 21 through 23. 21 through 23. Next Thursday, 2425, review sheet for chapter 2. And next Thursday is the quiz on chapter 2. Okay. That doesn't look right. The 29th is review. That's the day we actually do the review, and then the 31st is test. Halloween is not a holiday. Okay. Because I was absent from school yesterday, we lost an office hour to do the chapter 1 bonus. So I'm extending it one day to Thursday. So you have until Thursday to come in to do the chapter 1 bonus problem. Thursday, all the way through noon to 12:50 office hour. Please see the announcement that I put up last Tuesday night on the 8th for more details. Kind of list what problems you might want to think about looking at before you just show up to do the bonus question. You might want to give yourself a fighting chance. Okay. And then on Thursday, tests and grades. If not, then Tuesday, and I will put on a one bonus. And if not, then when you get it next week, I would be able to put if you did the chapter 1 bonus, I'd be able to just put that on there, so you wouldn't have to do a second grade report. Because if I have them ready for you on Thursday, this won't be in there. From last Thursday's notes, solving linear equations, step by step. The 5th step, check your work ifness or check your answer if necessary, play it into the original problem. Why not know if you got it right? Okay, and that's what we're going to do here with these examples. And then we'll continue on with the homework examples for 2122. We've got a few left. And by the way, question number 1 right there. In section 2.2, number 28. I'm taking care of a few. So we're doing this one right now. Question number 2 right there is question number 33. We'll take care of this one right now. Question number 5 right here is 40. And I'm throwing these on here as well because they're fraction problems, but these are 36 and 38 from 2.2. So this is 2.2, number 28, 2.2, 33. This one is 2.2, this is 38, and that's 36. This is 2.2, number 4. Step one, simplify both sides completely. If you have fractions, undo the fraction. Okay? If you have decimals, the question will tell you, definitely on a test, to round to a certain decimal place. On the homework, it may not say. But just whenever I see the homework questions and they don't say, I just look in the back of the book and round to whatever they have. But you have to, if you're going to round to the nearest tenth, you need to know it's in the hundred. If you're going to round to the nearest hundredth, you need to know it's in the thousand. So whatever you do, don't round until the very end. Work with all the decimals until you get to the end of the question. Don't be lazy. And that's what I see is laziness. I don't want to write all the numbers out because I have my hand. Well, then you don't want to get it right either. Simplify both sides. Both sides are simplified. You cannot do anything on the left side. They're not like terms. That's only one term, so that's leave that alone. Step two, separate variables and constants. Gather variable terms, and I put this separately. Variable terms on one side, constants on the other. Focus on the variables first. Focus on the variables first. So you either want to bring the variables onto the left side. If that's the case, you would subtract 0.5x from both sides. Or you want to take the constants to the right. Now, here's the deal. If you bring the variables to the left, then you have to take the constant over to the right. If you bring the variables to the right, then you have them separated. You have your constant on the left and your variable on the right. You're only going to have to make one move. But if you're going to bring the variables to the left, you got to make two moves. Here's what I know goes through people, goes through their heads. Well, if I take them to the right, I have to subtract 3.6x, 0.5 minus 3.6, that's negative. I don't like negative. So I'd rather subtract 0.5, and that way it's still positive. But then they forget that this is here, and they don't put 0 on that side. They mess that part up. They don't complete the problem. All they're doing is focusing, I don't like negatives. Well, life's not that simple. We deal with a lot of negative in life. My whole life, up until I met my wife, and I like the thing. That's what lives in a hole. It would be easier, and easier is relative, but it's fewer moves if I go ahead and just keep track. I mean, you do get to use a calculator, minus 3.6x. On the left-hand side, that's a negative 8.2 equal to 50 cents minus 3.60. So a negative $3.10. Negative 3.1x. When you make this move, when you subtract 3.6x from both sides, you better put the x there. Because if you don't put x, those aren't like terms. You can't just take away 3.6 from a 3.6x. They're not like terms. You didn't undo the 3.6x. Okay? When you're bringing this to the right, you better include the x, or else you're not moving it. Don't bring in this as a negative here. This is now separated, variables on one side, constants on the other. They didn't cancel out, we still have variables. Undo multiplication and or division. This is negative 3.1 times x, multiplication. So we divide both sides by negative 3.1. Yeah. So over here, this is positive x equal to a negative over a negative is a positive answer. And 8.2 divided by 3.1. And this is what I mean by rounding at the end. 2.64516.129. And if they said round to the nearest tenth, the tenth is the 6. So that 4 is going to leave it a 6. 2.6 would be the answer. If they said round to the nearest hundredth, then we're looking at the 4. And the 5 is going to round that 4 up to a 5, would be 2.65 would be the answer. How do you know what to round to? I'll look at the back. I don't have the answers for you. You see. Yeah, think of the answer as a fraction, which is ridiculous. So I won't even trust that back in the book. Because I'm not going to make you write it as a fraction. Follow it step by step. And I want to point this out. We're just worried about solving. Look at the directions right here. Write the equation in the form of f of x equals 0. So they want you to write it as a function that's equal to 0. I don't want you to worry about any of that. I just want you to solve the equation. We're worried about solving the equation. So make a little note to yourself. On these homework questions, 27 to 39 every other time. Solve the equation. That's solve for x. That's all we're focused on. Solving for x. We'll talk about what that means, letting the function equal 0, but we're just focused on solving it.
For what questions?
39 on the homework. 20, 27 to 39 every other. On 33, number 2 here. Simplify both sides completely. On the left-hand side, we cannot combine anything until we undo the parentheses. Inside 100 minus x, you can't do anything but, so we distribute 0.40. So 0.60x. This is distribution, so positive times a positive is going to be a positive. 40 cents times 100. 100 is going to move this decimal 2 times. 40 cents times 100 is 40. And then 0.40 times negative x is negative. 0.40x. You know why it's a good idea to put the 0.40? Because some of your handwriting is so atrocious, you do this. You barely can see the decimal point. So you forget the decimal point was ever there. Or because it's 0.40 times x, you're not going to bother putting the 0, so you just put, 0.4 times x, so it's going to be 4, very lightly, it's too dark. Yeah, that's still too dark. Yeah, and then x. But you're looking at that saying, well, that's 4x. It's not 4x, it's not 40x, it's 0.040. Okay. If I have the 0 in front, the only thing it can be is a 0 in front of me, 0 point, and 0 in the ones place, and then 0.40 for the tens equal to 1 point. On the left-hand side, you're not done simplifying. 60 cents times x minus 40 cents times 60 cents minus 40 cents is 20 cents. So 0.20x plus 40 equals 1.2. Everything is simplified, left side and right side. Now we want to separate variable and constant. This is the only variable term in the whole equation, so we're leaving it here on the left, which means we have to undo this positive 40 and take it to the right side. Subtract 40. (0.20) times x is equal to negative 38.80. Negative 38.8 would be fine, because that's what your calculator would probably say. I took it to the nearest 100 because this is the 100th place over here. When we divide both sides by 20 cents, first thing I'm looking at is going to be a negative. Now we're just looking, and I already messes this up. I divided by 20 cents, but over here we divided by 20. We just want to know how many times can 20 cents go into $38.80? How many times does 20 cents go into $1? 5 times. I have $38, so 38 times 5. And then I have an extra 80 cents, and that's another 4. So it'd be 38 plus an extra 4. That's 150 and a 40, so 190 plus 4. It's going to be 194. Is that right? Do you remember how to do long division with decimals? Because what this is, we know it's going to be a negative. It's 38.80 divided by 0.20. So 0.20 is the divisor, 38.80 is the dividend. So you just need to move the decimal 2 times that way. If I move this decimal, because you never ever divide by a decimal. So you move the decimal 2 times that way, so I have to move this decimal 2 times that way. And you actually are dividing 20 into 3,880. And you know what happens, why we can do that? Is because if I multiply this by 100 and this by 100, that's what moves the decimal 2 times. Then 3,880 divided by 20 is 194. You go to 388 divided by 2, and you get 190. All the same. But I like to look at it in terms of money. How much does 20 cents go into $38.80? Number 2.2 over 38. X minus 5 over 10 is equal to minus x minus 3. Let's see, over 5 equals 1. We have an equation. How many total terms are in this equation? How many things? Individual things. When? I can't. 2. Total, the whole, both sides, left and right side. Oh, 3. First 3. You have 2 on the left and 1 on the right, so 3 things. So when I undo the fractions, that's right here, simplify both sides completely, undo fraction, I have to multiply all 3 things. So the least common denominator for a 10 and a 5 will be what? 10. Because if I want to undo a 10, I have to multiply by 10. So I can reduce the fraction. If I multiply this by 10, will it also undo a 5? Will 5 go into 10 even? Yeah, so 10 works. If you choose 5, well, 5 goes into 5, it then does this fraction, but 10 does not go into 5 evenly. We have something left, down here. So the least common denominator has to be divisible by both of these. The first number that both 5 and 10 go into is 10. But you have to multiply every term in the equation. Every term in the equation by 10. So in this first term, the 10's reduced. All you have left is x minus 5. Be careful here. Minus minus 5 goes into 10 2 times. And we're left with that minus 2 times. We still have this x minus 3. I'm going to bring it down. We're left with minus 2 times that x minus 3 equals 1 times 10, which is 10. And I'm just bringing that step down so you can see, what's happening. If you distribute up here, just make sure you include the negative. So you can go from here to what I'm about to show you. X minus 5, negative 2 times x is negative 2x. Negative 2 times negative 3, that's a positive 6, equals 10. So if you can go from here to here, that's fine.
just make sure you distribute, it's -2 times x minus. Any questions so far?
Now, we're still not done with step one. We undid the fractions, simplified both sides completely.
On this left side, how many x's do I have? Well, two things with x's, two terms with x's, but what do I get when I go x and a -2x? What do they think? Negative what? Negative 1x. 1x minus 2x. 1 minus 2 is -1. 1x minus 2x is -x. Add one of them and a -2 of them, combine together, 1 minus 2 is -1. And then the constants, what about -5 plus 6? +1. -5 plus 6 is a +1. Equals 10.
Gotta get the x minus 2x. 1x
Minus 2x. What's 2x minus 1x? Positive 1x. 2 minus 1 is 1, so 1 minus 2 is -1.
Who wins?
Here, the positives win because the positives have more. There's 2 more x's. This is x plus x minus x. 2 x's, x plus x. 2 x's added together. Take away 1x. Those cancel out, make a 0, so we're left with x. This is 1x, and then we take away 2x. Minus an x is minus an x. Those make 0, so what do we have left? We have -x left over. Okay. Simplify both sides. Now we want to get variables on one side, constant on the other. So if I don't like the negative, I'll put it over here. Well, if I put the negative over there, then I got to bring the 10 over here. This is the only x in the whole equation, leave it there. Take the 1 to the right. So don't forget it is a -x. Equal to 10 minus 1 is.
But you need to remember, at the bottom of the box on a test, it's going to say, what does x equal, not what does -x equal. So remember, please, this right here is exactly the same thing as saying -1 times x equals 9. Anytime you have something that's a negative, it's -1 times it. Just like when you have a positive, if I have +5, that's 1 times 5. There's a 1 times 5 right there, same thing. If I have -5, well, that can be rewritten as -1 times +5. I mean, 1 is like a superpower. So if I want positive x, then I divide both sides by -1. A negative divided by a negative is a positive. And over here, a positive divided by a negative is a -9. So if -x equals +9, then positive x would equal the opposite negative. You know, step 5 over there, check your answer. You get peace of mind, you have the time, do it. So if we have -9, we're going to plug it into the original question. Don't plug it into something here, because obviously this should solve this part.
That's where it just came from. What if you did something crazy here and changed the original question in the wrong way? Then we just solved not the original question, but something we made out of the original question. It's not right. So you want to see if we solve the original. So if we plug in -9 into here, -9 minus 5 over 10 minus -9 minus 3 over 5 is supposed to equal 1. This is -14 over 10 minus, this is -12 over 5. Simplify. 14 and 10 have a common factor of 2. So this is -7 times 2 over 5 times 2. So -7 over 5. What's minus a negative going to be? Positive, so that's going to become plus 12 over 5. -7 over 5 plus 12 over 5 is positive 5 over 5.
When I plug in that answer, yeah, it works.
So number 4 is 2.236. X minus 3 over 25. That's equal to x minus 5 over 2. I'm going to read this one. So as you can see, I did 36, well, 3/4, which is 38, 36 out of order. I did 38, then 36.
This is where it gets a little. You get stuff, I don't, confusing maybe, because you start to mix and match rules that you've heard in the deep dark shadows in one place and you think it applies everywhere you go. I've heard of this somewhere, so I'm just going to do it all the time. And it doesn't apply. Have you heard the phrase cross multiply? Well, I see people doing cross multiply everywhere. Especially when it doesn't apply. When you're adding or subtracting fractions, cross multiplying doesn't work because guess what? The word multiply doesn't apply to when you're adding or subtracting. If you have more than 2 terms, like number 33, cross multiplying doesn't work. Cross multiplying only works when you have a proportion, like number 4 right here. A proportion is when you have one ratio equal to one ratio. A fraction equal to a fraction. You can cross across the equals, you can cross multiply. You can cross multiply. But this does not apply right here because you don't get to just multiply that by 10 and that by 5. You got to do the same thing to everybody because what about the 1? So it comes down to, you know what always works? Undo the freaking fractions by multiplying by the least common denominator. That's what works every single time. Undo the fractions, multiply every term by the least common denominator. You know why cross multiplying works? Is because it's undoing the fractions by multiplying by the least common denominator. Okay?
Here's what cross multiplying is gonna give. So I'm gonna write this down over here. X minus 3 over 25 equal to x minus 5 over 12. If you have a proportion, a fraction equal to a fraction, x minus 3 is to 25, as x minus 5 is to 12, solve for it. You can cross multiply. So x minus 3 times 12 is going to equal 25 times that x minus 5. No more fractions. But if we do it this way, the least common denominator for 25 and a 12. It's going to be what? 300. Because you know what? The only thing going into 25 is a 5 and a 5. The only thing going into 12 is a 3 and a 4. The only time they actually won't go into the same number is 25 times 12. The first number they both go into evenly is 25 times 12. The least common denominator is 25 times 12, 300. Okay, you can list all the 25. 50, 12 doesn't go to that. 75, 12 doesn't go to that. 100, 125, 150, 175, still 12 doesn't go. 200, 225, 250, 275, 300. 12 will go to that. Okay. So least common denominator, 300. Which is 25 times 12. 25 goes into 300 12 times. I get 12 times x minus 3 equal to 12 goes into 325 times. I get 25 times x minus 5, which is cross multiplication. But if it was 3 terms like this one right here, would not work. Because of the 1 and the fact that this is not a proximity sum. I'll be doing different numbers to 2 things on one side of the equation. So undo the fractions, multiply by the least common denominator, simplify both sides completely. 12x minus 36 equals 25x minus 125. Now we pick a side. Which side do you want to take the x's to, the left or the right? Great. Take it to the right. Focus on one side for the x's. So we're going to subtract 12x from both sides. 12x minus 12x cancels out. We're left with a negative 36 equal to 25x minus 12x is 13x, and there's a negative minus 125. Since we took the x's to the right side, we're going to bring the constant over to the left. We have to undo negative 125, so we add 125 to both sides. So we're going to get 90. Positive 99 equals 13x. See, I've got trying to work upside down. So we've got to borrow, so that's going to be 1. Yeah, 8, it isn't. 8. 89 equals 13x and divide by 13. is 13 going to 89. No. So it doesn't reduce. Leave your answer as a fraction in lowest terms. No decimals, leave it as a fraction. Lowest terms is 89 over 13. That one simplify both sides completely. So we have to multiply that out before we can actually even solve. X squared plus 2x plus 1 plus 2x minus 4 equals x squared minus 2x plus x minus 2. Now, if you're looking at that going, what in the hell did I do? Then I look at your test and I'm going, what in the hell did you do? Don't want to use the special products. Then you might want to make sure you remember to at least, this is x plus 1 times x plus 1. So we get x times x, that's x to the second. X times 1 is plus x, 1 times x is plus x, 1 times 1 is plus 1. So there's x to the second. 1x plus 1x, that's the 2x right here, and then there's the plus 1. And then I distributed positive 2 times x minus 2. 2 times x is 2x. 2 times negative 2 is negative 4. Equals. Over here, all I did was distribute. Positive x times x is x to the second. Positive x times negative 2 is negative 2x. 1 times x is 1x, is x. And then positive 1 times negative 2 is negative 2. All I did was the multiplication. Simplifying is just do your order of operation. Over here, exponent, gotta do that exponent, gotta do this multiplication. Now I'm going to add and or subtract, combine like term. X squared. 2x plus 2x, that right there is going to add up to 4x. Positive 1 and a negative 4 makes a negative 3 on this left-hand side. Equal on the right-hand side. X squared. Negative 2x plus 1x is negative x. And a minus 2. Simplify both sides completely. So step 2 is done. Chuck, step 1 is done. Now, step 2, gather all the variable terms on one side. And if you notice, we have 2 terms that have a variable. We have an x squared, we got an x to the first. This is section 2.1 and 2.2. 2.1 and 2.2, solving linear equations. Linear is x to the first, not x squares. So this is just here to mess with you. Let's get all the x squared on the which side, left or the right?
Right.
So if I bring them over to the right, I'm going to subtract x squared, I'm going to subtract x squared, and look what happens. There's no more x squared. So that was just there to mess with us, to make us think, I can't do this. This got x squareds in it. Well, the x squareds don't matter, they're going to cancel. So we still have 4x minus 3 equal to negative x minus 2. We still have variables that we can solve for, but the x squareds are not going to be a part of the answer. We're not going to have to worry about that changing our answer. Now, 2.4, 2.5, then yeah. Right now, then. So we still are in step 2. Now, which side do we want to get the x on? Left or right?
Right.
So yeah, better if you bring this negative 1x over to the right. So to undo a negative x, we add 4x plus 1x, that's 5. Minus 3 equals a negative 2. And since we brought x to the left, we got to take the constant, the negative 3 to the right. So you add 3, 5x equals negative 2 plus 3 is positive 1. So what's the last thing I gotta do? Divide by what? Make sure you have the right answer, don't get it wrong. X equals. Is it 5 or is it 1/5? 1/5. I will see that turned into 5 by some people. Not to say names. Because it's just, your brain, your eyes, they start playing tricks on.
So that's the wrong thing to do to think of 5, because I'm one of those people who do 5.
Right, so if I have a fifth of a piece of pizza, or do I have 5 pizzas?
Okay.
So I have 1 pizza divided by 5, so 5 slices. Versus now it became 5 pieces. 5 whole pizzas. So that's the difference between a fifth of $1 versus $5. So, 1 is on the top, it's 1/5. If it was 5/1, now you have 5. This one, that one. We gotta go back to 39 and 36. So the rest of the example from 2.1, this is about 39. And then going backwards into 36. Because 36 takes something for granted that probably needs to be done in review, which is the topic for Thursday's correct. If you're not a fan of factoring, that's what we'll be focusing on and Thursday's correct. F1, simplify both sides, undo fraction. We have fractions. And we don't want to deal with it. So we want to multiply every term by the least common denominator. Well, here's the good news. To undo this denominator, I can see the factor. To undo this denominator, I would have to multiply by an x minus 4 and an x minus 2. Because that's what's in this denominator. X minus 4 over x minus 4 reduces, x minus 2 over x minus 2 reduces. But if I multiply one term by this product, I got to multiply each individual term by the same product. I got to multiply everybody by an x minus 4 times an x minus 2. Every term gets multiplied by the least common denominator. What's really nice about number 39 is that the factors are right in front of your nose. Here's this one comes factor. That factor is one of these two factors, and x minus 2 is also one of these two factors. So if I just use these two factors, it undoes everything. It'll undo all of the fractions. Versus 36. If I'm going to undo x minus 2, then I have to multiply by an x minus 2. Everybody has to get multiplied by an x minus 2. If I'm going to undo this denominator, x plus 3, then I also have to multiply everybody by an x plus 3. And if I'm going to undo this denominator of x squared plus x minus 6, then I have to multiply every term by the x squared plus x minus 6. Because according to, what we just did over there, we got to multiply everybody by the same thing. Which is going to start to get messy. Unless maybe there's something that actually is part of that question is like this one. Which is why I wish they would have asked, this is 36 and that one's 30. You see how in 39, this left-hand side, this denominator is factored for us, but over here it's not multiplied out. So we know what the common denominator is comprised of. All the factors are in front of us. Over here, if I'm going to get a common denominator, I would like to know what factors go into that. Maybe it is x minus 2 and x plus 3. If it is,
I don't want to multiply by that crap, or just multiply by x plus 2 and x minus 3. So what you have to do, if you have something like this, is you can factor first, because you don't want to do something insane. Why? This being a college algebra course, you are supposed to have factoring, like back in your hand. You know how to factor. So that, again, so I'm gonna be doing reviewing on, at the co-rec on 8:30 on Thursday, Wednesday tomorrow, and Thursday for both co-recs. That'll work it back. So over here, this one reduces, all we have left is a 2. Equals. X minus 4 reduces, x minus 1 times, x minus 2 times 1 is all you have. Which is just like plus x minus 2 reduces, all we have left is 2 times, and x minus 1. No more fraction. Simplifying, finish simplifying with right hand side. So there's 2 equals x minus 2 plus 2x minus 8. 2 is equal to 3x minus 10. Now, good, add 10 to both sides. Separate the variable and the constant. And then what? Divide both sides by 3. And we get x equals what? 4. So at the bottom of the box, you put no solution. Oh, forgot to tell you. Yeah. Yes, give me a second. Okay, so. we put- Whenever you have fractions and your variables are in the denominator, remember that thing called domain? You're not allowed to divide by what? 0. Dividing by 0. So we're supposed to solve this problem. When we solved this problem, we got rid of fractions. And the only possible answer, the only thing that might work is a 4. This 4 is the answer to the problem without a fraction. But the original question has x minus 4 in the denominator. The only thing that might work makes this term undefined. So the only thing that might work won't work, so this whole thing has no solution. So here's what we actually would have discussed beforehand. I wanted to do it this way to give you that, oh, now you tell us kind of a response. When you have a variable in the denominator, we might have a problem. You got to think that through. And I'll tell you, I don't always remember to do it. We have a variable in the denominator. That means we have to be on the lookout for answers we have to throw away. They're called extraneous solutions or extraneous roots. They're answers to the problem that you changed it into, but they're not answers to the original question. So when you have a possibility of answers that you cannot use, up here, if we get a 4 or if we get a 2, if we get a 4 or a 2, they're not going to work. So be on the lookout for 4s and 2s. The only answers that we have to throw away. If we don't get a 4 or 2, then we're okay. We'll call it good. Maybe we check it. You can always punch it up on a calculator to see if it works. But we have to be alert to the fact, just in case, maybe something would happen that we just tossed. Now, if it was x minus 2 over a 2, this is okay. There's no problem with the x in the numerator. It's when you have that 2 over this x minus 2. When x is in the denominator, we run into trouble. So over here now. What would cause this to equal 0? X cannot equal what then? A positive 2. This x better not equal what? A negative 3. Because if I get a 2, 2 minus 2, that makes a 0. If I get a negative 3, negative 3 plus 3, that's a 0. So those would be the two bad numbers, extraneous solutions that would have to be tossed out just in case. Be on the lookout. You guys ever see War for the Planet of the Apes? Daddy? He reminds me of my dad. Because my dad was like, bald, and he always wore like a jacket vest all the time. So that bad ape reminded me of a little hat. Oh, you see that? I just see my dad. Those would be the bad apes. Can't be a 2 or a negative. Now over here, sure enough, x squared plus x minus 6 is going to be x minus 2 times x. So part of what we're going to do on Thursday, first times first, you multiply, you're going to get x squared. What's the only way you can multiply and make an x squared? X times x. It has to be an x times x. So what you're doing is, when you factor that polynomial, x squared plus x times x, you're undoing the distribution that happened. You're undoing the FOIL. You're breaking it apart. So the only way you can get x squared is because you multiply first times first. You got the x squared. Then you focus, I'm going to do it step by step. You focus on the signs. Forget about the rest of the numbers. Forget about all the rest of the term. It's about signs. And it's about the last sign. This last sign is made by this sign and this sign. This sign times that sign is a negative. The only way you can get a negative sign here is a positive times a negative is going to make a negative sign. The signs have to be opposite. That's the only way you can multiply and get a negative. Positive times a negative. Maybe it's a negative times a positive. We can switch them. But it has to be a positive and a negative. If it was a plus, then my sign's going to be a positive positive or a negative negative. And then we just focus on the 6. I don't care about this middle term. We figure out the middle one next. But last times last is 6. Well, there's two ways you can make a 6. It's either 1 times 6 or 2 times 3. If I try 1 and 6, in the middle, I want x. Outside is negative 6x. Inside is positive 1x. That adds up to negative 5x. That's not what I want. If I switch the 6 and the 1, then I'm just going to get positive 6 and negative 1. Positive 1.
So 1 and 6, I try to do both ways, like putting a puzzle together. Try it this way, they don't fit. It's not 1 and 6. So then I'm gonna try the 3 and the 2. So I try 2 and then 3. Outside, x times -3, -3. Inside is positive 2x. -3 plus 2 is -1. I don't want -1, I want +1. So putting it together this way doesn't fit. If you have the right amount, I want 1, but I want positive, not negative. Don't switch the numbers. Switching the numbers won't always work. Switching the signs will always. Outside is now +3, inside is now -2x. 3x minus 2x is +1, which is what we want. I'll break that down on Thursday. So sure enough, the factors for this is 4 over x minus 2 times an x plus 3. So my least common denominator is going to be x minus 2 times x plus 3. I'm gonna put out right now. Do you see how I multiply each individual term by x minus 2 and x plus 3? I don't like write it once and then like put arrows to the whole thing. Or write it once and then somehow maybe go to the next step where some are gone and so on. I can only demonstrate how I hope you do it, so you don't lose things along the way. Now, what you choose to do when you turn in your test and I say, show your work has to justify your answer. I'm showing you how I hope you do it. If you choose not to do it that way, hey. X minus 2 reduces. We're left with x plus 3 times 1, which is just x plus 3. Plus x plus 3 reduced. I'm left with x minus 2 times that 3. What do I have on that right side? Just the 4. Because the x minus 2 reduced and the x plus 3 reduced, and we need 4 only. Now we better simplify. Gotta distribute the 3. So x plus 3 plus 3 times x. And 3 times -2 is -6. X plus 3x, that's 4x. 3 minus 6, positive 3 minus 6, -3 equals 4. Add 3. And 4x is equal to 7. Divided by 4. 7/4. And 704 is not one of our bad apes. So you know what? Let's just check it. Let's plug in 7/4. So this would be 1 divided by 7/4 minus 2 plus 3/7/4 plus 3. And that's equal to 4/7/4 squared plus 7/4 minus 6. The least common denominator, the only denominator causing trouble is a 4. So I'm going to multiply these three terms in this fraction, in this complex fraction, by a 4. You get a 4? You're going to. So we get 4/7 minus 8. Plus, same thing here, 4/4. So that's going to be a 12/7 plus 12. Equal to, here, this is 49/16. When I square that, 49/16. Plus 7/4. So the least common denominator here is 16. So everybody gets multiplied by 16. So 64/49 plus 28 minus 96. So this is 4/-1 plus 12/19 equal to 64/what? Negative -21. Is that right? That's -19. So this is -4 plus 12/19. So we're going to need common denominators. We got to multiply by 19/19. 19/19. So that's going to be 86. No, 76. And -76/19 plus 12/19 equals -64/19. -76 plus 12 is -64/19. It works. Can't be afraid of practice. That was 36. 43. So 43, 47, 54. 54 is worth. And I want to point out, you see this right here. Solve for the indicated variable. So you're given an equation, given a formula, and you're supposed to solve for a variable. I want to point out the similar question on quiz prep. And give you a picture of a pyramid. The volume of a pyramid is 1/3 xy times 8. base of the area times the height. Solve for H. So you get to choose here. 43 or 47. 43, area of a triangle is 1/2 base times height, solve for H. Or 47, the volume of a right circular cylinder is pi times r squared H, solve for H. 43 or 47? $47.
Is that for more?
You're doing 23 to 47 every other odd and number 53.
And then the word is so.
So right circular cylinder is volume is pi r squared, the area of the base times the height. A right circular cylinder is basically this. Pi r squared. Pi r squared is the formula for the area of the circle and then times the height. All we want is H. What is the H equal? This is what V equals. What is the height equal? Undo what's being done to the height. Are there any fractions? No. Is there anything we can simplify on either side? No, there's no like term. We can't do anything. Separate the variables from the constant. Well, there's nothing we can add or subtract from either side because we don't have any addition or subtraction. Undo what's being done to H. The only thing being done to H is being multiplied by pi r squared. So to undo what's being done, divide by pi r squared. So H is equal to the volume divided by pi r squared. That's it. That's the formula for the height. If rate times time equals distance, what does time equal?
Or D, or C.
How can it be multiplication? Over here we have times.
Yeah.
What would you have to do to get time by itself?
Divided
Divide by what?
R.
Divide by?
R.
Here. Distance divided by the rate. Remember, distance, okay, is in miles, and then when rate is in miles per hour. So this would be miles divided by miles per hour. We want time, which is hours. When you divide by a fraction, you're going to multiply by the reciprocal. Miles times hours over miles. We're left with time only. It's all dimensional analysis. The units tell you how to do what the problem is asking you to do. The units. And 54. When am I ever gonna have to use this? Oh, here's word problem. I don't like word problem. A store generates Monday through Thursday sales of 150, 125, 75, and 180. What sales on Friday would give a weekday average of 150? So in other words, how much do we have to sell on Friday to get an average daily sale of 106? How do you do an average? So we add them up and divide by how many we have, so how many do we have? No, how many we're gonna have, will we want the whole weekly out? We're gonna have 5. But one of them we don't know, so here's why you guys, when I say you guys, I mean everybody in this freaking country can't figure out what call. If you don't want to use a variable. If you're gonna solve a word problem, you need an equation. And if you're gonna have an equation, you need a variable in there to represent what you're supposed to solve for. Because you're not just supposed to look at it and guess. You're actually supposed to come up with an equation that we can solve. It's gonna look like this. Monday plus Tuesday plus Wednesday plus Thursday plus Friday divided by 5 is equal to 150. So Monday is 150 plus Tuesday is 125 plus Wednesday 75 plus Thursday is 180. Well, let's just call Friday. I was gonna put TGIF, but that's too many variables. Divided by 5 days equals $150. Now, before you go getting rid of the variable happy, 150, that's 275, plus 75 is 350. 350, that's 450, plus 80, that's 530. That's 530 plus Friday, don't know yet, over 5 days is 150. We can undo the denominator by multiply both sides by 5, 2 fractions or 2 terms. This gets multiplied by 5 and this is 530 plus Friday equals 750. So now how do I solve for Friday? Subtract 530. Friday is equal to $220. That would be big gain. To average $150 for the week. And that's because Wednesday was storm. But if you want a comic book shop on Wednesdays, that's the best day, because that's when you comic book. At least that's how my dealer makes a whole lot of money. The one you have to do $53 to get an A in the course, you must have an average of at least 90 on 4 tests of 100 points. So the scores on your first 3. '93, '91, '84. Okay. And don't worry about writing a verbal line. What is the last score need to be to get a 90 in the class? How many total tests would you have? More tests. And you want a 90 over here. And you want the average to be 90. Same question, different concept, different number. So it takes care of that. 2.2. We have 45. Okay, 45 and 47, 54. Those are graphing calculator questions we can do on Thursday. The other aspect of what we're looking at are the words x-intercepts and y-intercepts on 2.2. So an x-intercept, and we talked about this before. An x-intercept is where the graph crosses the x-axis. A y-intercept is where it crosses the y-axis. And the most important concept is if it's an x-intercept, if it's an x-intercept, it's on the x-axis, anything on the x-axis, the y-coordinate is always 0. If you're on the x-axis, the y value is a 0. This doesn't have an x-intercept because this will never equal 0. This has two x-intercepts. So the y value is 0 2 times. This has one x-intercept, the y value is 0. This has two x-intercepts, the y value is 0 twice. But the actual x-intercept itself is the x value, the x coordinate, whatever that x coordinate is. So when you want to solve for the x-intercept, you let y equal 0 and solve. Y equals 0 and solve. The y-intercept is on the y-axis. We've done this already because we've done y equals mx plus b. There's the y-intercept. X is always 0. If it crosses the y-axis, the x coordinate is always 0. Okay. If you notice, you don't have to have an x-intercept. You can have multiple x-intercepts, but you can never have more than one y-intercept. You find a y-intercept, you let x equals 0 and solve for y. Let x equal 0, that's your y-intercept. Let y equal 0, that's your x-intercept. And we'll break out the calculator and show you how that happens, how it works on Thursday. And then the rest of Thursday, square roots, you're going to get that before you just leave. I got 1 minute. So I'm going to show you what you're getting. You're getting a push prep for 2122, but you're also getting this. List of perfect squares, cubes, fourths, and fifths. So these perfect towers, like 25 to the 5th tower, you're not going to need to know by heart, but I was busy making the graph. But you are going to need to know some of these. The more you know, the better off you're going to be. Okay. Perfect squares, definitely perfect squares, because we're going to be doing square roots. Because you might want to know that the square root of 484 is exactly 22. Square root of 625 is 25. The more you know by heart, the easier your life is going to be. So I'm posting this and I'm posting the push prep. Now I'll see if there.
Listen, I still want, I have a quick question, but 27, the one that's written on the board, is that just